our team, Jenning My Raider, and this is the Yank It, Crank It. So we were challenged with using human power to generate enough power to charge a bright light and to charge a phone while being portable and universally available.
Some objectives we had for this design is it needed to be small and portable. It needed to provide at least 5 minutes of flashlight time per minute of usage. It needed to be able to charge a phone, and then it needed to show voltage and power output on displays, and it needed to be easy to use.
We also had a couple of constraints and goals, starting with budget of maximum $230. Parts needed to also be ordered only from reputable vendors like McMaster-Carr or Amazon. It needed to be no larger than 2 cubic feet in volume and no heavier than 30 pounds, and it needed at least an output power of 5 watts.
So for the functionality of the prototype, you'll see this in the demonstration later, but we have fully custom electronics. So what this means is a custom milled PCB that handles the voltage rectification, energy storage, and voltage regulation. We also have a magnetic, removable, brightness adjustable flashlight. We have a custom herringbone gear train with approximately a 50-to-1 gear ratio. We have full metal-to-metal force transfer. So we have an aluminum U-channel for the gearbox leading to a steel pedal, foot pedal. And then we have a custom housing to hold it all.
And talking real versus ideal, with just 1 minute of Jenning our Raider, we were able to get 5 minutes at least of brightness off of our flashlight and generate between 5 to 10 watts. It's a very small size, can easily fit inside of a backpack. It weighs only 5 pounds. We came in well under budget at $138.85, and it really does not take all that much effort to use with just 1 or 2 people.
Some future improvements we would make would be using metal gears for better wear characteristics, also for reducing noise. Additionally, we would redesign the spool to help the rope not slip as much. Also, we would use higher power electronics, and hopefully the whole design would be much quieter.
Jenning My Raider.
This is the Yank It, Crank It. You put your foot here and you pull on these ropes to generate power. Going inside, we have a fully custom herringbone gearbox for an approximately 50-to-1 gear ratio. We get about 7,000 RPM on the motor. Over here is our electronics. We do fully custom electronics. This handles the rectification, the voltage regulation, and the energy storage. On the side, we have 2 switches. These control the flashlight and the USB port. And then for the flashlight, we have a removable magnetic base. So the flashlight turns on and on with this button, and adjustable brightness. It's a little bit dead right now.
Rip.
And then we have a full metal U-channel and pedal. So we have the aluminum U-channel, so all force goes through metal and not through plastic, and this ensures durability. And then on the front, we have 2 displays. The top displays the voltage, and the bottom displays the watts, so the user always knows how much power is coming in and out.
Now it's time to see the Yank It, Crank It in action. Nick is going to pull the generator for a total of 1 minute and then see if the flashlight will stay on for 5 minutes. As you can see, when Nick started pulling, the 2 LCDs turned on and displayed output power and voltage. This is a good sign of power being generated. After just a minute of pulling, the flashlight has accumulated a significant amount of energy and is ready to be tested. This also isn't just any ordinary flashlight. The custom modeled and 3D printed casing holds 3 powerful LEDs controlled by a brightness potentiometer sitting in a custom CNC channel, allowing users to easily choose their perfect level of brightness. Electrical energy in the flashlight is stored in 2 super caps and utilizes a custom PCB to regulate discharge. Now it's time to test if the Yank It, Crank It can power a phone. Before Nick presses the button to route power to the phone, it isn't charging. But as soon as the switch is flipped, charging begins. Nick has an easy time pulling, as both of the ends of the cord are guided through 2 steel rods, and the foot pedal makes it impossible for the housing to move. As you can see, as long as the generator is being used, the phone stays charging. And that's it for the project. The Yank It, Crank It not only hit its objective, but it also taught us a lot about integration, design, and teamwork. Thank you for watching, and we'll see you in the next one.